So continuing on our quadratic functions, we will find in this session the general form, the standard form, and learn how to write the quadratic function in the standard form and solve some more problems. So let's start with what is a general form of a quadratic function. So the general form of a quadratic function, guys, is given by fx equals ax squared plus bx plus c. Remember, in the previous sessions, we were talking about this is a polynomial of degree 2, and that's how we basically talked about a quadratic function. So now what we're doing is we're giving it a proper terminology, and we say that this is a general form. There's another way of writing a quadratic function, and that is the standard form. In a standard form, and in both of them cases, I forgot here, a is also not equal to 0. The standard form is a times x minus h, then the brackets close, the whole square plus k. Now, and a is non-zero. This a, guys, is the same as the a over here. Please be very, very careful. So these two a's are the same. Either it can be the general form or the standard form. The a component, the constant term in both of them is exactly the same. Now, in a standard form, we have actually added another two variables which are called h and k. The h and k together are nothing but the vertex of the parabola. So h represents the x coordinate and k represents the y coordinate for the vertex. Now, it is very helpful when we want to sketch a parabola. Remember, when you say, if I have this function, say, x, so it's x squared, which is the same thing as saying x minus 0, the whole square plus 0. And when we have been drawing this graph, this is how we have been drawing the graph, where the vertex is the point 0, that is the origin for us. So it's much more easy because we just have to look at two things when we are sketching a quadratic function if we have it in the standard form. Is the coefficient positive? And what are the vertex coordinates? Once we know that, we are basically able to have a rough graph of our quadratic function. Now, talking about the axis of the parabola is the line which passes through the vertex. In this scenario where it is h and k, so that's the vertex. For the example we have, the axis of the parabola here, according to the formula, this is x equals h. The axis in this example is x equals 0. Now, we have talked about it earlier too, and let me repeat. When the coefficient of x squared, which is a over here, is positive, that means the parabola opens upward. On the other hand, if the coefficient, say here I have a simple example, minus x squared, my a, which is the coefficient of x squared, is negative 1. That means the parabola is going to open downward. Okay, we are going to look at the following. These are the steps. So we're going to first talk about the steps before I do examples with you. The steps to write the quadratic function in the standard form. So, for example, if the graph is given as ax squared plus bx plus c, we would like to describe this graph and identify the vertex. And clearly, if you remember, just right now we talked about this is the general form. So most of the time you'll be given a general form and we will be asked to write it in the standard form. So how do we do that? To write a quadratic function from a general form to a standard form is by completing the square. Now that's what we did last chapter. So how do we do that? The first thing we do is we group the terms that have the variable x. So let's look at an example, 2x squared plus 8x plus 7. So we're going to group these two terms together. Now, remember, the idea is to complete the square. And completing the square, we want the coefficient of x squared to be 1. So what do? We factor out what is the coefficient of x squared, which is 2, from this expression. When we do that, what do we get? 2, parenthesis open, x squared plus 4x, parenthesis closed, plus 7. Now it is over here, this inside part, where we're going to complete the square. And this is going to how it looks like in the end. I will show you in the examples below how do we get that. Once again, we're going to talk about how to find the completing the square. We'll go through the whole process. At this slide, I just want to give you the general idea. How do you write a general form of a quadratic function into a standard form? One simple rule: you have to complete the square. Okay, now let's go and do some examples. So we're going to describe the graph of fx equals 3x squared minus 6x plus 16, and we're going to identify the vertex. So the first step, we gather the first two terms which are having the variable x. In other words, we're going to write this as 3x squared minus 6x. We group them together and put parentheses on either side, plus 16. Now when we go and look inside this parenthesis, x squared has a coefficient which is different than 1. That means we take this 3 out. When we take the 3 out, what do we get? 3, you open up the brackets, x squared minus 2x, close the brackets, plus 16. Now we're going to complete the square inside this parenthesis. Now I'm going to remind you, if you've forgotten, suppose you're given ax squared plus bx plus c. How do we complete the square? We write down here what is my a. So my a here, I'm talking of how do we go and complete the square here. Okay, so I'm looking at this one. My a is 1, my b is minus 2, and my c is 0. Okay, when we complete the square, we look at b over 2. Now b is minus 2. So you write minus 2 over 2, you get minus 1. Okay, then what do? We take b over 2, the whole square, which is minus 1, the whole square, which is 1. So what you do is you add and subtract b over 2, the whole square. In other words, we'll be adding 1 and subtracting 1. That's what we do. After that, notice that the first 3 terms, we always put the positive part of b over 2, the whole square, and then we subtract that one. Exactly the same thing, but the opposite inside. So notice that x squared minus 2x plus 1 is a complete square. And how do we write it down? We write x, then write down b over 2. This is what goes, guys, here next to x, minus 1 the whole square, because the first 3 terms are basically a complete square. And then what is left is minus 1, and your parentheses are right next to it because 3 is multiplied to every term inside, plus 16. So now we have done completing the square. What is going to be done next? We're going to take 3, and then we are going to distribute 3 inside this. So we'll have what? 3 times x minus 1 raised to the power 2. And then 3 times minus 1 minus 3 plus 16. So my fx is now written as 3 times x minus 1 the whole square plus 13. Or, make my life simpler, I can write this as 3 times x minus 1 the whole square plus 13. Notice from this graph that this is the standard form of our quadratic functions. Let's go ahead and look at how we're going to look at the description of what this standard function tells us. Once again, this is what? 3 times x minus 1 the whole square plus 13. We are going to match it with the general form we started with. So remember, this is the same as fx equals a times x minus h the whole square plus k. That's the standard form in a general scenario. So, making the comparison here, guys. What is my a? So what is a over here? A is 3. What is h? Now this, guys, minus is always there. So this h is 1. H is 1. K is 13. So what does that tell us? This is the vertex. The vertex is 1 and 13. Okay. Now the graph A is positive, right? That means the graph opens upward. Now remember from your transformations, as it is minus 1, that means it has shifted right. It has shifted right by 1 unit. And what does plus 13 means? It has shifted up by 13 units. Okay. And this graph has what is the vertical what, guys? And this one, this vertical stretch, the number is the coefficient that is A, basically also tells it is a vertical stretch or a shrink. So it has a vertical stretch by a factor of 3. Remember in the transformations we learned about movements up and down, movements right and left, vertical stretches and shrinks. So shifting is basically left and right, up and down shifts. And stretches or shrinks are the ones which are multiplied to the coefficient of the squares. Okay, so here it is it's not coefficient of the squares, it is the vertical stretch is basically dependent upon A. That A is multiplied to the square of that expression. So here the square is x minus h the whole square. Okay, now let's look at another example. So how would this graph look like? Just to have an idea, if you can put it in your calculators, let me just show you how the graph would look like. Now remember, it is 1 and 13. Okay, let me just make it so I just need to have this. Okay. It's 1 and 13, so I'm just going to eyeball this. That's the vertex. As A is bigger than 1, that means it's going to be a vertical stretch. Vertical stretch means the graph becomes narrower. So our graph, then the normal graph would be more narrower. Okay, that's how the graph would look like. Okay, going on to the next example, guys. Now we would like to describe the graph of this function minus 2x squared plus 16x minus 31. Okay, now first we have to complete the square. So what does that mean? Graph the terms which has the expression x to it. Then take minus 2, the coefficient of x squared, out. You're factoring that out. So what do you have? Minus 2x squared minus 8x, because remember when I multiply minus 2, I should get the original equation. Okay? Now, we're going to complete the square in this part. Remember, what is my a? A here is 1 and b is negative 8. So what are we going to do here? We're going to add and subtract b over 2 the whole square, which is what? Minus 8 over 2 the whole square, which is 16. Remember, we always put plus 16 first. The plus is always put first. So this is what we are doing, guys, over here. This is this. What we add is what we subtract, because the original problem, remember, cannot be changed. So this one becomes what? This. So this whole expression, guys, x squared minus 8x plus 16 is a complete square. And how do we write it down? It's a negative here, so x minus 4 the whole square. Okay, this minus 4 is, how does this minus 4 come about? This minus 4, remember once again, is b over 2. Okay, now, so it is minus 2 x minus 4 the whole square. This minus 16 pops down, and then we close the brackets, and then we have negative 31. Okay, now simple math is now we distribute negative 2 inside this expression. We get negative 2 x minus 4 the whole square plus negative 2 with negative 16 is a plus 32 minus 31. Do a simple math. This is minus 2 x minus 4 the whole square plus 1. Okay, let's do a description of this quadratic function. Okay, so our function was minus 2 x minus 4 the whole square plus 1. So from here a is what, guys? Minus 2. Remember the expression we are trying to equate it to. A x minus h the whole square plus k. So what is h? Minus has to be there, guys. So minus is here, so it's fine. H is 4. K is 1. So what is the vertex? The vertex of the parabola is h and k, which is 4 and 1. Now, graph opens downward. Why? Because it's a negative 2. This graph opens downward. Now, how much has it shifted? Minus 4 means it has shifted right by 4 units. And plus 1 means it has shifted up by 1 unit. Okay, now does it have a vertical stretch? Yes, it has a vertical stretch because negative 2, remember the number is greater than 1. Oh, sorry, the number is, I'm looking at the absolute value, which is 2, okay? So this one, it is a stretch. Minus, guys, always reflect it is the graph opening upwards or downward, okay? When you're looking at the stretches, you look at the absolute value of A. So it has a vertical stretch by a factor of 2. Okay,